All right, so we're going to be looking at slopes now. We're going to be going right into linear functions, which are lines, linear line, right? So we're going to be looking at the slopes of a line, and whenever I say that word slope, we're looking at a rate of change over a period of time. All right? So if I were to plot some points of data, which we're going to collect and whatnot pretty soon here, if I plot my points, and I do my line of best fit that we were doing before, my rate of change over time, as I look for the points from left to right, if I look how the points are changing over time, they're going up. So whenever you have a rate of change that is upward, has an upward slant, all right, we're looking at a positive rate of change. So this upward slant is going to be a positive slope. So how does that line change over time? And time generally is going to the right. Next, if I have my points, and we're going to collect some data, right? And when I gather my data, and if my points from left to right, if my points, when I do my line of best fit, go down from left to right, over time, my line's going down. I have a downward slant, right? Downward slant. I have a negative slope or a negative rate of change over time. All right, so we all read left to right. So from left to right, this was upward, positive. From left to right, this is downward, right? Downward, going down from left to right, is negative. Well, what happens if I have some data points, right? I have some data points that are horizontal, right? It doesn't look like it's going upward. It doesn't look like it's going downward at all. It's horizontal. Horizontal. Well, really, we have like no rate of change. It's not going up. It's not going down. So no rate, no change, just means we have a slope that's zero. Zero slope. My slope is zero. I have no rate of change. No change occurring over time. All right? Great. So, with our data points, we're going to be given ordered pairs. All right? And ordered pairs would just be points given in a parentheses that have the first part, that's an X. The second number would be a Y. So you've seen this before. Somebody said plot 2, -3 on a coordinate plane, right? Well, the 2 is my X, and that second number, -3, that's your Y. So if I have 2 points, Euclid said the distance between 2 points is a straight line. If I have 2 points, I'm going to have a second X and a second Y. So this first point will be my X1, Y1 for the first point. And the second point, that second point we're looking at would be my X2, Y2. All right? So if I wanted to look at the rate of change between those 2 points, what I would do is I would find my change in Y over my change in X. All right, the change in Y over the change of X. So essentially, to find how it changes from one to the next, I'm going to subtract. All right, so let's go ahead and write that formula out, and then we'll go through some examples, all right, of this rate of change. So my slope is unknown. When it's unknown, we use a variable. So for the rest of your lives, all right, in math, in Algebra 1, Algebra 2, M, that letter M, lowercase, will represent our slope. So the letter for slope will be M. Slope. All right? And when I'm trying to find a rate of change, I want to do my change in the Y's over the changes in the X. And you've heard this before, rise over run, but we'll get into that. Don't want to get ahead of stuff. Let's look at the formula. So how my second point is different, remember different means subtract, than 1, or than my first y, over how my second x is different than my first x. So different means subtract. We're looking at how the change, how the difference is, right? So we're looking at how the y changes, the change in y, over our change in x. All right, so there's our formula. All right, and that change in y over a change in x is also known as our rise over run. So I know you guys did some of this in middle school, so we're just kind of putting it all together now, but you know, it's been a while, so we're definitely going to do some examples to help you remember in just a moment here, okay? So hopefully you got that written down. If at any point you need to go back, pause it, write down, rewind, listen again, you can. But that's where we're at so far. All right? So let's look at the change of slope between 2 points. All right? So here on the next sheet, I'm just going to draw a little coordinate plane. My x is from left to right. This is my x-axis, just as a review. Up and down, here's my y-axis, right? So let's just plot some 2 points. And the 2 points we're going to look at, let's look at 3 and 9. All right, and let's look at -6 and -5. All right, so 2 points. The first thing you want to do is you can plot the points, but I like to label them. I like to say which ones are my x's, which ones are my y's. The first number is your x. So first point, first x, right? The first number, first point gets the x1. The second point, the first number in the second point is my x2. So that's the second x. We're just showing this is my first point, second point. Second number is my y. So the first point, y1, all right? And the second number in the second point, my y2, all right? So x1, y1, x2, y2. Good. Let's talk about how to plot again, all right? So you always, x comes first, so we're always going to do our x to the right here. This is our positive numbers, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So to the left is negative, -1, -2, -3, -4, -5, -6. And then to the right, 1, 2, 3, 4, 5, 6. All right? So positive to the right, negative to the left. All right? So first I'm going to plot my 3. Well, 3 is positive, so I'm going to go to the right 3. 1, 2, 3. All right? Don't make that point yet, because we still have to go up. So to the right 3, positive 3, and then 9, positive 9. Positive 9 is up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 up. So positive 3, up 9. That's the point 3, 9. So there's my point 3, 9. My second point right here, -6, -5, we got to do the x first. So negative is left. Negative is left, as you can see in the number line here. So we got -1, -2, -3, 4, 5, -6. All right, so there's my -6. And then the y is saying we end up at -5. So negative down for y. So down 1, 2, 3, 4, 5. All right, so to the left 6, down 5. All right, so I'm going to plot that. There's my -6, my -5. Right? So this is just a quick review. So like I said, this guy Euclid, he was a Greek guy, right? He said that the distance between 2 points is a straight line. So I'm going to go ahead and do a line of best fit between these points. And in this case, we only have 2, so they connect nicely. So what I want you to tell me right now is just by looking at this, by connecting these 2 points, do you think that's a negative slope, a positive slope, or a 0? So left to right, is that going a positive slope, a negative slope, or zero? So what I would think is that, you know what, I don't know. You can look back at your notes, right? So we're looking back at our notes right here, and I'm comparing it, and I'm looking from left to right. It seems to be going up. So if it's going up, upward slant, this is a positive slope. Excellent. All right. So that's a positive slope. My M should end up, my final M should end up being positive. So now let's go ahead and practice using that formula down here that we used with these 2 points. So I'm going to write it again, because writing it again will help us remember it for the future, right? So there's my formula. Here's my formula for the 2 points. And we labeled them x1, y1, x2, y2. So let's just substitute it in. So what's my y2? -5, right? So I got -5, and then minus, what's my y1? 9. All right? All over, and remember fraction bar means it's a divide, right? Same as divide. x2, -6. And then in the equation I got a minus, so I'm going to put my minus in. And then my x1 is 3. All right, great. So now that we have that, we can simplify. -5 minus 9. So if you struggle with negatives, you can definitely check your work with the calculator. But I like to look at it like this. I owe you $5, and I owe you 9 more. So I owe you 14, right? But if you're struggling with those negative integers, definitely use the calculator to help you out. I owe you 6. I owe you 3 more. How much money do I owe you? I owe you 9. All right? Good. So we're almost done, right? I got my slope right here. But if I look, I can simplify this one more time. A negative divided by a negative is a positive, right? So that makes sense, because look at the line. It's an upward slant. So my answer should be positive. All right, so positive 14 over 9. All right? And you can turn that into a decimal easy enough. You just go ahead and divide. All right, 14 divided by 9. All right, and you can get your decimal right there. For now, though, let's just leave it as 14 over 9. So if I were to do my rise over run, if I wanted to find other points, I would rise 14 and run to the right, because it's a positive 9, run right 9. All right, so I'd go up 14 and run over 9. And so if this line were to keep going, it would hit this point right where my finger is right there. All right? So there is how to use the slope formula, which I'm sure some of you learned in middle school. And then positive slopes, upward slants, downward slants, negative slopes, horizontal, no change. Your slope would be 0, M would be 0. All right, so this is your intro to defining a slope. There's going to be some more videos for you to watch, but make sure you have all this written down in your notebook. All right, let me know if you have any questions.